Today we're going to be graphing systems of linear inequalities. It is exactly like graphing just a regular system of equations, except that instead of finding where the lines cross, you're going to be finding where the shaded parts overlap. So you'll have two or more inequalities graphed together. We'll actually do one today with 3. And then your solution, like I said, is going to be just like last time, the set of all the points that makes the inequality true, but in our case, it'll be where the shaded parts overlap. You do need to make sure that both equations are in slope-intercept form before you start. We'll do that several times today. First, graph. Graph the system of linear inequalities. Our first equation is y is greater than 1/4 x. Okay, so that would be the line that starts at 0 and has a slope that goes up 1/4. So it starts, I'm going to do color coding since we have 2 today. Starts at 0 and goes up 1/4 because it's positive. Okay, it's greater than, no line beneath, so it should be dashed. Like that. And let's go ahead and shade. It is greater than, so we are going to shade above the line. And I'll go ahead and do this in blue. Great. Next line, I'll do in red. It starts at 4 and has a slope of -1. So starting at +4, it goes down 1/1. And it is less than or equal to, so we should have a solid line here, and I'm trying to draw it straight. That was pretty good. Okay. Because it is less than or equal to, I'm going to shade below the line. And you'll see when I do this that there will be a section where the shading overlaps. Okay. So do you see how in this part right here the shading overlaps? That is my solution area. Actually, the only answers that count are in here. So you have a couple options for me. You could shade in this part darker, or what you'll see me do today is actually erase the extra. So if this works well if you're using pencil, because this is not the part that is in the overlap, I'm going to erase the shading. You could leave it and just shaded this darker, take a pencil and put it really dark. I just need to see obviously where is your solution area. Next one. This one is harder because both equations are in standard form, which means that before you start, you actually need to get them both into y = mx + b. We'll do one at a time. Whoop. Okay, the first one, I'll rewrite this. 3x + 2y is greater than -2. Okay. I have to move the x term to the other side. So I'll do that by subtracting because it's positive, which means that my new equation is 2y is greater than -2 minus 3x. Have to get y by itself, so I'll divide by what's in front of y. Another way that you can write this, you could do one division bar, or you can split it up. I'll do it like that on the next one. So it would be y is greater than -2 divided by +2 is -1. And then -3 divided by 2 ends up as -3 halves x. Okay, let's go ahead and graph that, and I'll graph this one in blue. Starts at -1, and goes down 3 over 2. Does not have that line underneath, it's just greater than, so it's going to be dashed. And because it's greater than, we are going to shade above the line. All right, let's do the next one. X plus 2y is less than 2. First thing we do is move the x term. So I will subtract x. And remember, this is just 1x. Okay. So my new equation is 2y is less than 2 minus 1x. If I divide by what's in front of y, and make sure we divide everything by 2. This is another way you could write the division. Then my new equation would be y is less than 2 divided by 2 is 1. We're simplifying. And then you leave this one as negative 1/2. So I'll do this equation in red. Starts at 1 and then goes down 1 over 2. It is less than. So we're going to have a dashed line again, because it's not or equal to, ooh, I messed up that last point. If you see it. This one, that's wrong. Okay, so dashed line. And because it's less than, I shade below. You can clearly see, hopefully, where they overlap, which is this section. So on the last one, you saw me erase the extra. Remember, your other option is to just shade in, like this section is my answer. And so you could just shade it in really dark to make it obvious for me. I think on Math Excel, you will actually have to think about where the overlap would be. So if you wanted to like graph it on a whiteboard or something first, that might be helpful. Other thing I need you to know how to do is writing a system of inequalities from the graph. So you have to look at the two equations that are going on. The first one I see here is this guy. So that is the line. It starts at 5. So that's my y-intercept, and it looks like it actually has a slope. So it's here, and then doesn't actually hit another point until down here. It has been shaded below, you can see, because the overlap is in this section. So less than, it has to be less than because it's dashed. Negative 5, 6 would be my slope because of this triangle here. Goes down 5 over 6. You can look at those 2 points. X, and then plus my y-intercept is 5. The other point is, sorry, the other line is here. That would be the line x equals 2, except this is an inequality. So we're going to make it x is greater than or equal to 2. I know it's greater because it's been shaded to the right, and that's where numbers get larger for the x's. So those are your two equations there. Last system actually has 3 equations. The first 2 are actually very easy. The last one, I want you to make a change for me. I actually want this not, so we're actually going to do this instead. X minus y is less than or equal to 4. Okay, so change that out for me. Let's graph the first line. I'll graph this one in red. X is greater than or equal to 2. That would be a vertical line at 2. Because it's or equal to, it's solid. Okay, like that. And to get greater than 2 for the x's, I have to shade to the right. Because if you look on your number line, numbers get bigger going to the right. So it doesn't follow the above or below rule if it's an x. We'll do the next equation in blue. Y is greater than or equal to -3. So that would be a horizontal line at -3. And it is or equal to, so it's going to be solid again. Because it's greater, I shade above. You'll start to see an overlapping section here. Last one I will do in black. But we can't actually graph it yet because we have to solve this equation for y. So first thing I do is subtract x to move it to the other side. And then I'm going to divide by what's in front of y, which in this case is a 1. So we'll divide by -1. Which means that my new equation is actually going to flip the sign because you divided by a negative number. So it's going to be greater than or equal to -4 plus 1x, because this is a negative divided by a negative. Okay, so let's graph that line. And it should also be a solid line because it's or equal to. And we're shading above the line because it is greater than. I should technically have this all the way over here, but I did not do that. Okay, hopefully now you can see the section where they all overlap. That would be right here. Ooh. So you can either just darken in that section or you can erase everything else. In MathXL, you'll have to figure out, like, after you graph the two things, where would the overlapping section be, and that will be the only spot where you highlight. So last thing here is two possible solutions. Okay, so two possible solutions, these would have to be in the shaded region. So you could choose any 2 points in the shaded region. I'll choose that one and that one. So here's two possible solutions because they're in that overlapping part. The point 4, 2 would make all the equations true. And the other one I picked was 3, 6. But any point in that shaded region will work, including the ones on the line here because they're a solid line. And then two that are not solutions, so stuff in a not shaded region, be stuff like out here, or even out here, even though it's overlapping with two things, because it's not where they all overlap, those are not solutions to the whole system. So 6, -6, and -4, 3. Those would be ones that are not solutions because they're not in the overlapping region in the part that's shaded. That's it.